So what we have been trying to do in the last slide and this slide is to define the cohomology groups associated with a sheaf. So there are a large number of cohomology groups associated with a sheaf: H0, H1, H2, H3 and so on. So on this slide we do acyclic resolution of a sheaf. In fact, we do not do any construct any resolution per se, but if we are given a resolution of a sheaf, we want to then define the cohomology groups of the sheaf in terms of that resolution. So there is a sheaf F and you are given a resolution of F in terms of other sheaves F0, F1, F2, F3 and so on. Now each of these sheaves F0, F1, F2, F3 and so on are acyclic. Now an example we had discussed before where we replace each of these F0, F1, F2 by D0, D1, D2, which were discontinuous sections and naturally flabby sheaves, thus acyclic. So these F0, F1 do not necessarily have to be flabby. The condition is they are acyclic. So if you have such a resolution, then the cohomology groups are easy to compute. So the cohomology groups are nothing but cohomology groups of the resolution on global sections. So basically the idea is how do we even compute or start computing the cohomology groups associated with the sheaf. So the sheaf F, there are multiple cohomology groups associated. There is group H0, H1, H2, H3, H4, H5, H6, H7. They are all these groups associated with the sheaf. And then these groups are also connected to each other. So what are the cohomology groups? So the cohomology groups, if you want to compute cohomology groups of the sheaf, you just worry about the global sections. So you start computing the cohomology of the following chain complex. H0 on F1, F2, F3 and so on. Obviously this is same as F0 of X, F1 of X. So I'm just writing H0 so that you know H0 and the global section are the same. So we have all these global sections on the entire space X, and you compute cohomology groups of this, and that is precisely the cohomology groups of the sheaf. So for any sheaf, in order to compute cohomology groups, first figure out the resolution of the sheaf. So you break this resolution of the sheaf. Yeah, this is the standard trick. You do 0, F, F0 and then you append Q to it. A surjective map. This Q0 is nothing but F0 over image of F, or here you can simply say F0 over F. And then you do this thing where Q0 embeds into F1 and then you have F2, F3 and so on. Yeah, because Q0 is F0 over F and this resolution is nothing but a complex. So you take the long exact sequence associated with the short exact sequence. Yeah, from F, F0, Q you form the long exact sequence. Yeah, then you come to H1, you have drawn H0, now draw H1, and once you start drawing H1 you should switch to acyclic conditions. Yeah, so H1 of X of F0, this has to be 0 now because F0 is acyclic. Yeah, F is just a sheaf, but F0, F1, F2, F3, F4, all those are acyclic sheaves. So H1 x F0, this is 0. Yeah, so we have a exact sequence from H0 xf all the way to H1 xf. So what is H0 x comma f? So this is nothing but kernel of the map, because this is an exact sequence or a long exact sequence. So H0 xf is kernel of the map phi 0, yeah, because of exactness of the sequence. Okay, now this embeds into F1. Yeah, this you can see from the other sheaf from 0 to Q0 to F1. Yeah, so you could apply H0 to that part also, and you will see it embeds in. In fact, there is injective map. So instead of kernel of phi 0, we can talk about kernel of this map, HXF0 to HXF1. So this is precisely what H0 would be if you start computing the resolution of the sheaf directly from the complex. Yeah, so H0 would be, if you look at the resolution from here, so H0 would be this, where I have ticked kernel of this map, because image of 0 would be 0 only. Yeah, so kernel divided by image is 0, so you just get the kernel. So for H0 it is clear, H0 xf is nothing but the same cohomology group which you will get if you compute for the resolution. Let us compute H1 x comma f. Now this H1 x comma f is a surjective map, yeah, because there is 0 after it. So it is H0 xq. So this is a surjective map, so it is nothing but H0 xq over image of H0 x f0, or you can just say image of phi 0. Okay, so now somehow we have to relate this to the chain complex or the acyclic resolution from like the acyclic resolution 0 to f0, f1, f2 and so on. So let us do this now. Now for this purpose, we will have to consider the second sequence also, 0 to Q0 to F1 to F2 to F3 and so on. So before I do that, I just want to elaborate on this. Image of H0 x F0 is nothing but image of this map phi 0 which I have written before. So instead of phi 0, I am just writing the complete map. Yeah, as said before, this H0 x comma q embeds into H0 x comma f1. So I will write it more formally now. You just take the second sequence, zero to Q0 to F1 to F2 and apply H0 to it. So we have this map, then you go to H0 to F2, yeah, we do not worry about going further up, although we could break this into another by appending another q, but we should not worry about it. You just have to see h0 x comma q injects into h0 x comma f1. Yeah, so we want to write this map as beta. So beta is the we will write this as beta later on. And what is h0xq? It is nothing but kernel of this map here, alpha. Yeah, because we have this exact sequence from h0xq to h0xf1 to h0x comma f2. So this is the map alpha here. Yeah. So now you see h1 x comma f is kernel of alpha over, say, image of beta. This is the map beta. h0 x comma f0 to h0 x comma f1, and that is the same map here, beta. Yeah, because h0 x comma q just completely embeds into h0 x comma f1. Or you can just take beta as a composition of these two maps. So for h1 of x comma f is again computed from the acyclic resolution of sheaves, kernel of alpha over image of beta. That is cohomology group of the acyclic resolution. H0 was also cohomology group of acyclic resolution. H1 is also. Now we want to talk about higher degrees. So for higher degrees, you always consider the short exact sequence 0 to f to f0 to q0 to 0. So that is the first short exact sequence which I have written, 0 to f to f0 to q0 to 0. So you apply the long exact sequence of cohomology groups onto it. So I should start with f, f0, q0 and then increase the index to x comma f to x comma f0 and so on. Yeah, so these two groups are 0 because again f0 is acyclic. So hi minus 1 xq and these are isomorphic. So the thing is that now for higher groups we just need to compute the cohomology of q. Yeah, but the cohomology of q is nothing but the cohomology of the acyclic resolution. Yeah, because q is always the quotient map. It is always kernel over image. Yeah, that is the way we are calculating. Always q is the, yeah, so q is always, for example, q0 was f0 over image of f. Similarly, we can talk about q1, q2, q3 and we can keep constructing q1, q2, q3 and they will determine the cohomology sheaf.